This is the video for section 5.3 notes, slides 16 and 17. All right, so another example here of using related rates. Suppose a liquid is being cleared of sediment by pouring it through a cone shaped filter. Assume the height of the cone is 16 inches and the radius of the cone is 4 inches. If the liquid flowing out at a constant rate of 2 cubic inches per minute, how fast is the depth of the liquid decreasing when the liquid is 8 inches deep? All right. So remember, we want to go back and we want to follow these steps, right? So we want to start off by drawing a picture. All right. So I draw a picture. So I have a cone shaped filter. Now, remember, this would be a cone that is facing this way, right? We pour. This water in and then it leaks out the bottom, right? And the sediment stays in the filter, right? All right, so you're told that the height of the cone is 16 inches, right? So that's the overall height of the cone is 16. I'm labeling it with a number because that is not changing. The radius of the cone is 4 inches, but remember that would mean that the diameter is 8. So just to kind of keep that in mind. All right. All right. So now we think, okay, so we draw this altitude line here. Now we have a certain amount of liquid in the tank, right? And so that isn't going to fill up the entire depth of 16 inches. Right. And so what we have is we really have the height of the liquid, which we could call H, and then the radius of the top of the liquid we can call R, right? Now, as the water flows out, the height will fall, right? And so that means the height is changing, right? And so then there is a dH dt, right? That is some negative number, right? And then the radius is changing, right? Because as the level of liquid falls, right, the radius is going to change. And so then there is a dr dt, which is also some negative number, right? Because it is decreasing, right? The radius is getting smaller as the liquid flows out. Okay. Now the liquid is flowing out, right? So there is a certain volume of liquid in the tank, right? And as it flows out, the volume is decreasing as well, right? And so then there is a dv dt, right, which is some negative number, but specifically we're told it is 2 cubic inches per minute, right? So negative 2 cubic inches per minute is the dvdt. Now, remember, it's negative because the volume is decreasing. So it's important that that isn't necessarily, it's not explicitly given to you in the text, right? It says the liquid is flowing out, right? So that means the volume is decreasing. So you have to put a negative there. Right. And then it says, how fast is the depth of the liquid decreasing when the liquid is 8 inches deep? All right. So let's go back to these steps. Okay. We draw a picture. Yes. Represent all rates of change as derivative. Yes. All right. So now find. All right. So step 3. All right. It says, how fast is the depth of the liquid decreasing? All right, so find what, when, what. All right, so find, well, how fast is the depth of the liquid decreasing, right? So what does that mean? Depth of the liquid is H, right? So dH dt. So find dH dt, right? When the liquid is 8 inches deep. So when H equals 8. All right, so we have that. All right, now, okay, go back to our steps here. Write a formula for relating the variables. Well, how are our variables related? We have R, H, and V. Those are our variables. 16 and 4, those are not our variables, right? Variables are things that are changing, right? And so we can say that volume, well, what's the volume of a cone? Okay, 1/3 pi R squared times H, right? So that is the volume of a cone. That's not something that you need to have memorized necessarily. You might recall from geometry, but really, this is something, well, okay, if we need to look it up, fine, right? That is the volume of a cone. All right, so now we have this, all right? Then it says differentiate implicitly, all right? And then plug in known values and solve. All right, so now if we were to differentiate this implicitly, right, we're going to have r squared and h, right? So that means we're going to have to use the product rule. So that means we're going to have r, h, and dr dt and dh dt in our problem, right? And that would be equal to dv dt. So that is an issue because we don't know both r dr dt and dh dt, right? So what we want to do is we actually want to take out this triangle here. So I'm going to take out this triangle that I have, right? And we can see that the overall triangle is 16 tall and 4 wide here. Now, the level of the liquid is R wide and H tall. And so we can use similar triangles, right? So we can say that 4 is to 16 as R is to H, right? And so now we can use this to relate R and H. And so then we can substitute either R or H out of our problem, all right? And then we can have an equation with only one variable there. All right. So what do we want to do? Well, we want to know dH dt, right, when h is 8. So we want to get rid of r. So let's solve this for r. So r is going to be 4/16, which is 1/4 times h, right? And so I'm going to plug in 1/4 h for r. So our volume equation then is 1/3 pi times r, which is 1/4 h squared times h, right? So now we want to simplify that. All right, so 1/3 pi, 1/4 squared, that would be 1/16 h squared times another h. And so then our volume equation, 1/3 times 1/16 is 1/48 pi times h cubed, right? Now that is our volume equation, and we want to then differentiate. All right, so differentiate implicitly with respect to time. So what is the derivative of sorry, not velocity, volume with respect to time? dv dt equals, all right, 1/48 pi times the derivative of h cubed. So that'd be 3h squared times the derivative of h, which would be dh dt. Okay, so now plug in known quantities and solve. Well, remember, we want to know dH dt, so that's unknown, right? We know h is 8, and we know dv dt is -2. So -2 equals, now I'm going to simplify here, 3 and 48 gives me 1/16 pi times h squared times dH dt. What is h? Well, we want to know dH dt when h is 8, right? All right, and so now we can simplify a little further before we solve. 1/16 pi times 8 squared is 64 times dH dt. All right, 64 and 16 reduce. This would just be 4. And so I have 4 pi times dH dt. So I'm going to divide both sides by 4 pi. So I get that dH dt is equal to -2 over 4 pi. Obviously, this reduces. And so dH dt is going to be -1 over 2 pi, right? -1 over 2 pi, what though? We're talking about the rate at which the height or the depth is changing. So depth would be measured in a linear measurement, so inches. So in inches per minute, minute is the unit of time. All right. And so that is example number 2. All right. So now let's go on to slide number 17. All right. Similar, but a little bit different, right? Okay. An airplane flew over an airport at a rate of 300 miles per hour. 10 minutes later, another plane flew over at 240 miles per hour. If the first plane was flying west and the second plane is flying south, and both planes were flying at the same altitude, determine the rate at which they were separating 20 minutes after the second plane flew over the airport. All right. So we're going to start by drawing a picture. All right. So this is, I'm just going to call this the airport. All right. Now we are looking at I mean, you could call it a bird's eye view, but remember, these airplanes are flying above ground. So we're really just looking at this two-dimensionally, right? So this is looking at from kind of the atmosphere. All right, so we have the airport here. One plane flies over. The first plane was flying west, right? And so we're going to draw a line indicating the path of the westbound plane. Okay. All right, and so we're going to draw it this way because that would be the logical way to draw something going west. Not really sure why it won't draw a straight line for me, but you get the picture. All right, so this plane is flying this way. All right, then we have another plane that has flown south, right? And so we would draw a line going downwards to indicate south. Now remember, we are looking at this from like a bird's eye view. All right. All right, now the question is, how far were they separate, or how fast, the rate at which they were separating from each other. So that would be this distance here, right? So now this is a right triangle. Okay. So what we want to do is we want to think, okay, the westbound plane was traveling at a rate of 300 miles per hour, right? Okay. So how far was it? Well, the distance that the westbound plane is from the airport, or from the point directly above the airport, let's call W, right? And obviously that distance is changing. So there is a dw dt. Okay. The southbound plane is flying, and after a certain amount of time, it is S miles from the airport, right? And that is changing. So there is a ds dt as well, the rate at which the south distance is changing. Okay. Now, these two things are a certain distance apart from each other, right? So we can call that whatever we want. How about z, the distance between the two planes? And obviously that is changing. So there is a dz dt. All right. So now what we want to do is we want to think, the westbound plane is flying how fast? Well, it says an airplane flew over the airport at a rate of 300 miles per hour. So 300 miles per hour, right? That would be the rate at which the distance is changing. Okay. DSDT, the southbound plane is flying at 240 miles per hour, right? All right, DZDT, that's what we want to know, the rate at which they are separating, right? So that is some positive value, right? Because that distance is increasing, right? But that is what we would like to know. All right, so then how can we relate these variables? All right, well, we know that this is a right triangle, so these would be related by the Pythagorean theorem, right? So we could say that s squared plus w squared is equal to z squared, okay? Now, we also want to write our find statement. I'm sorry, I went slightly out of order, right? So find what, when, what. Well, determine the rate at which they were separating. So that would be dz dt, that's what we've called it, when what is true. Well, it says 20 minutes after the second plane flew over the airport. So t, now I'm going to call it t sub s for the time that the southbound plane had been flying, which is 20 minutes. Okay, now units are very important here. The airplanes are flying at miles per hour, but this is 20 minutes. And so we need to make sure we convert, right? 20 minutes is 1/3 of an hour, right? Now that's T sub S. The southbound plane has only been flying for 20 minutes. What about the westbound plane? Let's call that T sub W. uh, if you look at the text, it says 10 minutes later, another plane flew over, right? So the first plane, the westbound plane, had been flying for 10 more minutes. So that'd be 30 minutes, right? Or a half of an hour. So it's very important that you remember those units need to match up. All right. And so now we have our equation relating the variables. All right. And so we want to differentiate. All right. But remember, implicitly with respect to time. So what is the derivative of s squared? That would be 2s times the ds dt, right? Plus, what is the derivative of w squared? That would be 2w times dw dt. All right, and then the derivative of z squared, of course, 2z times dz dt. All right, so now plug in known quantities and solve. Well, I know ds dt and I know dw dt, but I don't know s, w, and z. So how can I find those? Well, think about this. If the southbound plane was flying for 20 minutes or a third of an hour, right, at 240 miles per hour, right? So you can say that the southbound, the south value, the distance is the rate, right, in 240 miles per hour. Okay, and I'm going to put the units here just to make sure that we're paying attention to how these should work out, right? 240 miles per hour times the 1/3 of an hour, right? So we're really just taking 240 and dividing it by 3. So hours cancel, of course, and that is leaving us with a distance, right? Hours, right? And so we really are left with an amount of miles. So 240. So the southbound plane had flown for 80 miles. Okay. All right. Same thing we want to do with the westbound plane, right? So the westbound plane was flying at 300 miles per hour, right? And then times 1/2 of an hour. So of course hours reduce, and 300 divided by 1/2, or sorry, 300 divided by 2 or times 1/2 is 150 miles, right? So the westbound plane had traveled 150 miles and the southbound plane had traveled 80 miles. All right, so now we can use both of those with the Pythagorean theorem to determine how far the planes were apart, right? So I can say 80 squared plus 150 squared equals z squared, right? Now, of course, you can use the Pythagorean theorem to solve this, but it's a little easier than that. This is a Pythagorean triple, right? So remember an 8, 15, 17 triangle. So an 80, 150, 170 right triangle would be the case. So that means the two planes are 170 miles apart, right? And so now we can put in all of those known values and solve. All right. Sorry about this. My pen does not seem to be working well right now. All right. So I'm going to plug in the known quantity. So 2 times S. So remember, S is 80 times ds dt. ds dt is 240 plus 2 times W. So 2 times 150 times dw dt, which is 300. And then, of course, 2 times z, which is 170, times dz dt. And so now you'll see that we only have one variable left, dz dt, that we want to solve for. So now, really, this is pretty simple to solve, right? We just take and divide by 2 times 170, right? And then, of course, it's a calculation thing or it's an annoying thing to simplify, but that's really not the concern. The concern is the algebra. Okay, and this one actually turns out to be pretty easy. So dz dt would be 2 times 80 times 240. And yes, I know we can do this calculation, but I just want to make sure that we are doing the algebra correctly. So 2 times 150 times 300, and then all divided by 2 times 170, right? Now we can make things a little easier, okay? Uh, Everything has a 2, so we can reduce that. 170, 240, 300, we can divide everything by 10, right? And so this would get us 17, 30, and 24, right? And then it makes the calculation a little bit easier to do, right? And so we've got the calculation here. So we've got 80 times 24, right? So 1920 plus 150 times 30. So we've got 4,500, and then divided by 17, right? So 1920 plus 4,500 and then divided by 17 gives us approximately 377.647. And that would be in miles per hour, right? So really, though, obviously the calculation is annoying, but this problem is just using some geometry, some basic stuff, but within this larger context of related rates. All right, so that is